All right, so I'm going to go through with you guys a review in preparation for your upcoming quiz on chapter 1.5 A and B. All right, so we're dealing with complex numbers in this section, right? Imaginary numbers. I'll go piece by piece into every type of problem that you might see. All right, so I'll start with this page. We're going to be adding, subtracting, and multiplying complex numbers. So the key thing to remember here is you want to treat I like a variable, and you're going to replace I squared with -1. All right, so let's get started with number 1. Okay, we have 14 minus 7i plus 11 plus 9i. All right, so anytime you have something like this, again, you want to treat the I like a variable. You're going to do your real with your real. All right, so 14 plus 11 are your real numbers. It's going to get you 25. Imaginary plus the imaginary, right? So -7i plus 9i is going to get you plus 2i. All right, simple as that. You don't have to do anything else to it. In standard form, it is in standard form. If you remember, standard form is going to be our a plus bi, where a is your real and bi is your imaginary. All right, so if the question asks for an answer in standard form, right, you need to write it in this format, real plus the imaginary. Okay, so let's try the second one. All right, we should see something similar happen here. Right, we have the addition of two complex numbers. So we want to add real plus the real. Our real numbers here are 25 and 13 is going to give you 38. Imaginary plus the imaginary is 18i plus 6i is going to get us 24i. Right, and this is in standard form. We have our real number 38 plus our imaginary of 24i. All right. And now the next one, if we're subtracting, all right, all you have to do, just like in our polynomial section, right, the negative outside of a group of parentheses, you can distribute that. You can treat it like a -1. So it's just going to change the sign of everything on the inside. So we get 6 plus 11i minus 19 plus 4i. All right. And now that we have this, we can just combine real plus the real. Right, so 6 minus 19 should get you -13. And then imaginary plus the imaginary. So 11i plus 4i should get you 15i. All right. And now let's look at the next one. Again, we have a mix of a couple things here. We have some addition, some subtraction. Again, the negative on the outside is going to change the sign of everything on the inside. All right, so we should get 41 minus 32 minus 7i. All right, and then this plus is just going to change, is going to keep the sign, sorry, of everything on the inside. So 5 minus 5i is going to stay a plus 5 minus 5i. All right, and now let's combine. All right, real and a real is going to be 41 minus 32. It should just get you 9 minus, and then we have an imaginary of -7i and another imaginary of -5i, so we should get minus 12i. And then plus another 5, right? Don't forget about this 5 right here. We get 9 plus 5 is going to get you 14 minus 12i, right? In standard form, right? Real plus imaginary. All right. Number 5, this one we're going to be multiplying, right? So to multiply complex numbers, right, you want to FOIL this, right? This kind of looks like a binomial times a binomial. So we can do 7 times 3 is 21. 7 times 9i is going to get us plus 63i. And then -4i times 3 is going to get us a -12i. And then -4i times 9i is going to get us a -36i squared. Right? And I squared, anytime you see an I squared, that's the same as -1. That's the same as multiplying by -1. So I just cross it out and I change the sign in front and it becomes a real number. All right, so now we just combine real plus the real. So 21 plus 36 is going to get you 57. And then you get 63i minus 12i. So we combine our imaginaries now. We should get plus 51i. Right, so anytime you see an I squared, you can't leave it like that. You have to actually replace it with a -1 because that becomes a real number. All right, so this becomes our answer. All right, and something like this one, don't get confused on something like this one. To this day, I know that there are some of you that will just square the 4 and square the 5i, right? That is not what this means. You actually need to either just memorize the special product. I know weeks ago we did a special product with this, right? Where it was you square the first, square the last, and then you multiply the middle two, and then you double them, right? But a lot of you don't memorize it, which is fine. There's nothing wrong with that. You just need to actually FOIL it out, right? Write it twice, and then you want to FOIL it, right? So this is the same as 4 plus 5i squared, right? So just FOIL it, and you'll see that we don't get the same thing as if we were to just square 4 and square 5i, right? So 4 times 4 gets you 16. 4 times 5i gets you 20i. 5i times 4 is going to get you another 20i, and then 5i times 5i is going to get you 25i squared. And again, anytime you see an I squared, cross it out, change the sign in front. So it becomes a real number, negative 25. Right, so let's combine. 16 minus 25, right, should get you negative 9. And then 20i plus 20i should get you 40i. Right, so this is your answer in standard form. Right, again, it is not the same as if you were to square the 4 and square the 5i. Right, and then just adding them together, right? That does not work this way. You need to write it out twice and then FOIL it out. Right, but the actual process isn't as difficult as it may seem, right? It's just foiling. All right, so now we get into dividing complex numbers. All right, so to divide complex numbers, you need to rationalize the denominator by multiplying by the complex conjugate. Right, the complex conjugate, if you don't remember, is just the same. You get the same numbers, but you have an opposite middle sign. Right, so something like number 7 here. Right, 4 plus 2i in the denominator, that's a problem. We can't have an I in the denominator because the I is the same as a square root. And if you remember weeks ago, we don't want square roots in the denominator. That makes it not simplified. Right, so to simplify it, we multiply by the complex conjugate, right? In this case, the complex conjugate is going to be, right, it's going to be 4 minus 2i, right? You get exactly the same terms, just one is plus, one is minus. So if we originally had a plus, we're going to have a minus in our conjugate, all right? And the shortcut for this is going to be, if you have something in standard form, it's going to be a squared plus b squared, right? So basically the real number, right? So in this case, it's going to be 4. So 4 squared plus the real part of our imaginary. So plus 2 squared, right? You can do that instead of foiling it out, because when you FOIL it out, you should cancel out the middle terms, right? They're going to cancel out by when you're multiplying by the complex conjugate. All right, so this is just a shortcut. Just square the first term and square the real part of the second term. All right, and then on the top, we can distribute this 5i, and we should get 4i times 4 is going to be 16i, and then 4i times negative 2i is going to be negative 8i squared. But again, anytime you see an I squared, just cross it out and replace the sign in front with its opposite. Right, so we should get 16i and then plus 8 over 4 squared is going to be 16 plus 2 squared is 4, and then 16 plus 4 is 20. All right, so now let's simplify this. All right, so we want to do 16i over 20 plus 8 over 20. Right, and then after this, we're going to have to write our answer in standard form. Right now, the imaginary is the first term, right? But we want it to be the second term. It's always real plus imaginary. Right, so to simplify 16i over 20, right, simplify by a common factor of 4. So we should get 4i over 5. And then 8 and 20, same thing, divide by a factor of 4, right? So it becomes 2, and this one becomes 5, right? So 4i over 5 plus 2 over 5. Now in standard form, you have to write the real first, so it becomes 2 over 5 plus 4i over 5, right? And there's your answer. All right, let's try the same thing with the next one. right? It might be a little bit of a tedious process, but once you get the process down, it's going to be the same exact thing every time, right? Multiply the top and the bottom by the complex conjugate. Now, this one, I actually wrote it incorrect, right? So I want you guys to make this correction, right? It should be the real number first and then the imaginary, right? So it should be 5 over negative 4 plus 3i. All right. Now, now what we want to do is multiply by the complex conjugate, right? So the complex conjugate we can only do if it's in standard form, right? So write it in standard form, right? I should have done that before, but multiply the top and the bottom by the complex conjugate of negative 4 plus 3i is going to be negative 4 minus 3i. All right, so top and the bottom by negative 4 minus 3i. All right. Should get you on the bottom, again, use the shortcut, right? So we're going to square the real part of it. So negative 4 squared is 16. And the real part is 3, right? So so 16 plus 3 squared is 9. All right? And then that's going to give you 25. All right? And on the top, we can distribute 5. So 5 times negative 4 is negative 20. And then 5 times negative 3i is negative 15i. So right now we should have, right, something like this. I'll write it again just so that it's a little bit cleaner. All right, now to write our answer in standard form, we need to split it up into a real plus an imaginary. So we should get negative 20 over 25 minus 15i over 25. All right, and then they share a factor of 5. So negative 20 becomes negative 4. And then 25 becomes 5. Right, same thing here. 15 becomes 3. You can divide the top and bottom by 5. And then we should get negative 4 over 5. Right, that's our real part, minus 3 I over 5. All right, and this should be our answer in standard form. All right, now moving on to the next one. All right, so we have 2 minus I over 2 plus I. Again, multiply the top and the bottom by the complex conjugate. All right, of the bottom, if you see a complex number on the top, you don't want to get confused and do the complex conjugate of that, right? You're doing the complex conjugate of the denominator. All right, so it becomes 2 minus I on the top and on the bottom. And on the bottom, again, you can use your shortcut, right? So 2 squared becomes 4 plus, and then I. If there's nothing in front of the I, you assume it's a 1, right? Just like with variables, just like with radicals. All right, so we get 4 plus 1 squared is 1. All right, and then on the top, you want to FOIL this out, right? 2 times 2 gets you 4. 2 times negative I gets you negative 2i. Negative I times 2 is going to get you negative 2i. And then negative I times negative I is going to get you positive I squared. And then again, with the I squared, you want to cross it out, replace it with a negative 1. Right, so we get minus 1, right? If there's nothing in front of the I, again, it's a 1, right? So change the sign in front of that 1. And now let's simplify this a little bit. So we get our real, and our real on top is going to be 4 minus 1, which is 3. And then imaginary with the imaginary is going to be negative 4i over 4 plus 1, which is 5. And now to write it in standard form, just split it up, right? So this becomes 3 over 5 minus 4i over 5. All right, so same thing with number 10, right? We want to multiply top and the bottom by the complex conjugate of 5 plus I, right? So doing that is going to get us 5 minus I on the top and on the bottom, all right? Again, you can use the shortcut. 5 squared is going to get you 25 plus, if there's nothing in front of the I, assume it's a 1. So 25 plus 1 squared, which is 1. All right, and then on the top, we want to FOIL, right? 13 times 5 should get you 65. 13 times negative I should get you negative 13i. Negative 2i times 5 is going to get you negative 10i. And then negative 2i times negative I is going to get you plus 2i squared. But again, anytime you see an I squared, you cross it out, replace the number in front with a negative. All right, and now let's combine, reals with the reals is going to be 65. Minus 2 is going to get us a 63. All right, and then negative 13i minus 10i is going to get us negative 23i. All right, over 25 plus 1 is going to get us 26. And then to write it in standard form, you want to split it up. So we get 63 over 26, all right, minus 23i over 26. All right, and then neither of these can simplify, so you can leave it alone. All right, so now we get into simplifying negatives under the radical. To do these, you want to remove any negatives under the radical by replacing it with an I. And then you want to simplify anything else that's left over. Right, so something like number 11, we have a negative under this radical. So again, you can replace that with an I, right? But just to write it out, and I won't write it out like this every single time, but just to write it out, we're going to get square root of negative 1 times the square root of 50. Right, and then the square root of negative 1, this becomes I. And then square root of 50 we can split up, right? This is the radical that we want to simplify. So it's going to be square root of 25 and square root of 2. Right, factor it any way that you can, right? Find any factors. If you can't find the biggest one, that's fine. Just be careful with your factor trees if you make it. All right, and then square root of 25 becomes 5. Square root of 2 you can't simplify. So your final answer is going to be 5i square root of 2. All right, same thing with the next one. All right, we have a negative under the radical. You can take that out immediately. It's going to be square root of negative 1, square root of 147. And the square root of negative 1 we say is I. Square root of 147, you can split that up into 49 and 3. All right, and then square root of 49 becomes 7. So we should get as our answer 7i square root of 3. All right, next one. Now we're multiplying, right? With these, you want to take out the i's first, right? So if there's an I, or if there's a negative under this radical, take it out. So we get I square root of 12. Same thing here. Take out that I square root of 10. All right, and now let's simplify. I times I is going to get you an I squared. And then 12 times 10, both under the radical, you can write it as the square root of 120. All right, and then I squared is going to make our entire answer negative. All right, and then the square root of 120, we can take out, right, there's not very big ones that you can take out. You can take out a 4 and a square root of 30. All right, and the square root of 4 becomes 2, and then square root of 30, you actually can't simplify that anymore. All right, so your final answer should be negative 2 square root of 30. Right, and so we got that negative from this I squared, from doing I times I. All right, so this should be our final answer. All right, now let's try the next one. Same thing here, right? We have negatives underneath the radical. So we want to get rid of those first. We get I square root of 8 times I square root of 6. Right, there's a negative under there as well. And then I times I, again, is going to get you I squared. And then 8 times 6 is going to get you 48. Right, we've done this specific root a lot of times in class, right? So this, you should maybe recognize, should be the square root of 16 and the square root of 3. And then the square root of 16 is 4. Square root of 3 can't simplify. Keep in mind, I squared becomes negative 1. So we get negative 1 times 4 times the square root of 3 is going to get you negative 4 square root of 3. All right. Same thing with dividing, we want to get rid of that negative first, right? So we get we get I square root of 84 over I square root of 7, right? This I and this I are going to cancel out. And then you're just left with the square root of 84 over square root of 7, sorry. All right, and if you have two things that are being divided and they're both under a radical, all right, you can make this a little bit easier and simplify as 84 divided by 7. Right? And 84 divided by 7 is just going to get you 12. So we get the square root of 12. And then let's simplify this a little bit. It's going to be the square root of 4 and the square root of 3. And the square root of 4 is 2. So we get 2 square root of 3 is our answer for this one. All right, same thing with 16. right, you want to take out the i's first. So we get I square root of 18 over I square root of 2. I and I are going to cancel. Then you get square root of 18 over square root of 2. Since they're both underneath the radical, you can do square root of 18 over 2 and write it as a single radical. And then 18 over 2 is going to get you 9. And the square root of 9 is 3. All right. Now let's go on to this next section. All right, so we get into higher powers of I. We want to divide the exponent by 4. And the remainder is going to become your new exponent. Right, so a lot of you liked to see the cycle motion, right? It's going to be I, -1, negative I, and 1. Right, so I is going to be a remainder of 1. -1 is going to be a remainder of 2. Negative I is going to be a remainder of 3. And then 1 is going to be a remainder of 0, right? So it goes into 4 evenly. Right, a lot of you asked in class, why is it a remainder of, or why are we dividing it by 4? Because every 4, the cycle repeats, right? So after 4 units bigger in the exponent, the cycle repeats, so then that becomes equivalent. All right, so something like number 17, we have I to the 6, right? You can maybe do this in your head, but if you want to write out the long division, right, how many times does 4 go into 6? It goes into 6 one time, and then you get 6 minus 4, which is 2, right? So you don't care about the number up top, you only care about your remainder. If your remainder is 2, then this means I to the 6 is the same as I squared. But you want to simplify this more. I squared is the same as -1. So I to the 6 is -1. All right? It's going to be the same thing every time, right? So number 18. Divide 19 by 4, right? How many times does 4 go into 19? I think 4 times, right? So then 4 times 4 is 16. You get a remainder of 3, right? Again, don't care about the number up top. This is the same as I to the 3rd power. And I to the 3rd power, we said, was -I. All right? And now when we have negatives in our exponents, right, we want to first bring the negative down to the bottom, right, and make it positive. So we get 1 over I to the 9th, right? And now let's see what I to the 9th is, right? When you divide 9 by 4, it goes into 9 twice, right? Then you get a remainder of 1. So then this is the same as 1 over I to the 1st, or just I. But you don't want to leave it like this, right? I is the same as the square root of -1, and we don't want radicals in the denominator. So let's rationalize it by multiplying the top and the bottom by I. And then you get 1 times I is I. I times I is I squared, but I squared is -1. So we get I over -1, which is -I. Right, so I to the -9 is going to get you -I. All right, we want to do the same thing with number 20. Right, so we have a negative in that exponent, bring it to the denominator, and make the exponent positive. So we get 1 over I to the 12th, right? 4 goes into 12 3 times, and we get no remainder, right? No remainder means our exponent is 0. 1 over I to the 0. Anything to the 0 power is 1, so we get 1 over 1, which is just 1. So I to the -12 is going to get you positive 1. All right, lastly, let's solve some quadratic equations with complex solutions. You want to solve by taking square roots, completing the square by quadratic formula. Factoring is never going to work here, right? That should be your instinct, but here it's not going to work, right? And you want to simplify any radicals by taking out an I. All right, so let's look at number 21. Again, solve it however you want, right? Factoring is not going to work, but any of the other methods are fine. Right, this one looks pretty simple. We have a squared term by itself. So let's keep it on this side of the equal sign, and let's subtract the 49 on both sides. Right, because then we have a squared term equals a constant. Right, so x squared equals -49. And then to get rid of that squared, you want to take the square root of both sides. So we get x equals plus or minus. Right, that negative becomes an I, and the square root of 49 becomes 7. Right, so you get x equals plus or minus 7i. All right, 22 is another one that we can isolate our squared term. All right, divide both sides by 4. We get x plus 3 squared equals negative 20 divided by 4 is negative 5. All right, and then you want to take the square root of both sides. So we get x plus 3 equals plus or minus the square root of negative 5. And then you want to subtract 3 on both sides. So we get x equals negative 3 plus or minus. Square root of negative 5 becomes I square root of 5. All right. And then 23, we can solve it any method we want. I would do it by quadratic formula because even though our middle term is even, right, we have a number in front of the x squared, right? So that's going to make completing the square a little bit difficult. Let's just do quadratic formula, right? In this case, a equals 2, b equals negative 4, and c equals 11. All right, so just plug it in. All right, so x equals negative 4 is going to be positive 4, plus or minus the square root of negative 4 squared, minus 4 times 2 times 11, all over 2 times 2. Right, so as long as you remember the formula, these shouldn't be super difficult. So we get x equals 4 plus or minus the square root of 16 minus 4 times 2 is 8. 8 times 11 is 88. All right, divided by 2 times 2, which is 4. All right, now let's simplify this. All right, so we should get x equals 4 plus or minus the square root. 16 minus 88 should get you, right, negative 72 over 4. And then you want to simplify that radical, right? So the square root of negative 72, the negative becomes an I. And then the square root of 72 we can split up as the square root of 36 and the square root of 2. All right, and the square root of 36 becomes 6. So we get x equals 4 plus or minus 6i square root of 2 over 4. All right, and now we want to simplify this a little bit. All right, we get x equals 4 over 4 plus or minus 6i square root of 2 over 4. Right, so 4 over 4 just gets you 1. And then plus or minus 6 and 4 we can simplify into 3 over 2. Right, so plus or minus 3i square root of 2 over 2. Right, so I'll zoom out so that you can see the whole thing. Right, so a lot of steps for this one, right? But it's the most reliable method to use the quadratic formula. Right, so doing that, assuming you do it correctly, plug everything in right, then you should guarantee your answer every single time. All right, so let's do the same thing with the next one, 24. All right, so number 24, we have a equals 1, b equals 2, and c equals 12. All right, just plug it into the quadratic formula. We get x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 12. All right, all over 2 times 1. All right, so we get x equals negative 2 plus or minus 2 squared is 4, minus 4 times 1 is 4 times 12 is negative 48, and then over 2. And then 4 minus 48 is going to get you negative 44. So we get x equals negative 2 plus or minus the square root of negative 44 over 2. So we get x equals negative 2 plus or minus, and then you can take out the I, and you can also take out a 4, right? So it becomes 2i square root of 11, right? If you're not okay with how I did that, right, square root of 44 is the same as square root of negative 1 times 4 times 11. And then square root of negative 1 becomes I, square root of 4 becomes 2, and square root of 11 just becomes square root of 11. All right, and then you want to put this over 2, right? And then to get your final answer, you want to split it up. So we get x equals negative 2 over 2 plus or minus 2i square root of 11 over 2. And then your 2's are going to cancel out. So we should get x equals negative 1 plus or minus 2 divided by 2 is going to give us I square root of 11. All right, and that should be your final answer. All right, I hope this helps.